Okay, let's determine the values of k for which 2x squared plus 7x plus k equals 0 has no real roots. Has no real roots. Okay, and when we say that we have no real roots, what we mean is that there's no solution for x. So what would k have to be so that x, there is no solution for our value x here for this equation to equal 0. So remember that when we're talking about real roots or being able to decide how many solutions we can have, we can go back to the quadratic formula. So if you go back to the quadratic formula, remember that negative b plus or minus the square root of b squared minus 4ac over 2a. Let's just recall that this is what we use to find our x value, but specifically we're really concerned about this b squared minus 4ac. This piece of the quadratic formula is going to tell us whether we have no roots, exactly one root, and again, root meaning one solution or no solutions, no roots, one root, or two roots. And this happens, so when we have no roots, that means that this b squared minus 4ac, it has to be less than or equal to 0, because no roots means that I'm going to get something that's undefined or doesn't exist, and that will happen if b squared minus 4ac is negative, because remember, I can't take the square root of something that is negative. That will give me something that's undefined. So I want b squared minus 4ac to be less than 0. If I wanted one root, I would want b squared minus 4ac to equal 0. And if I wanted two roots, then I would want b squared minus 4ac to be greater than 0. In this case, we're looking for no real roots. So we are going to have to focus on this guy here. Okay, and in this example, a equals 2, b equals 7, and, well, I don't know what c is, and in fact, c is k, so I can actually literally just say c is equal to k. And now I know that if I replace b squared minus 4ac has to be less than or equal, or specifically, strictly less than 0, if I start substituting a, b, and c, I can rewrite this as 7 squared minus 4 times 2. And then because I don't know what c is, I can just say that, c is equal to k. So I can just replace it with k. And I know that that expression has to be strictly less than 0. So this is kind of like when we were looking at our restrictions and we were trying to solve, we're like trying to, look for that boundary point where I know that if I'm on the left of a particular value, like on a number line, if I'm on the left-hand side of a particular point, then that's going to give me something that works. And then if I'm on the right-hand side, that may or may not also give me something that works. So in this example, what we're looking for is we're looking for that boundary point. And that boundary point is going to take place when I set this inequality as an equation and I solve for k. So I'm going to actually, I'm going to ignore the inequality sign and I'm just going to say equals instead of the less than 0. And I'm going to say I have 7 squared minus 8k is equal to 0. So that's 49 minus 8k is equal to 0. And I want to make sure that my coefficient on k is positive, just so it's easier to work with. So I'm just going to move this over so I can solve for k, so I can figure out what k can or can't be, okay? So then I'm going to get 49 equals 49 equals 8k. And then I'm just going to divide both sides by 8. So I should get, so I'm going to divide this by 8 and this by 8. And we're starting to see that k equals 49 divided by 8. And that's okay. It's just a fraction. It's not a super nice number, but we're okay with that. So this is my boundary. K equals 49 over 8 is my boundary. So when k equals this number, this whole expression, the b squared minus 4ac will equal 0. So as soon as k is equal to 49 over 8, that means that I'm in this situation. This one that I'm going to highlight in blue here. Okay. I'm in this situation where I have equals 0. That means that there would be exact. So if k was equal to 49 over 8, that means that I would have exactly one root. Okay. That means there would be exactly one solution for this equation for it to equal 0. There would be exactly one solution for our value of x. Okay. But what I want in this example is I want no real roots. So I want no solutions, which means that if I go back to this inequality that I started with, which was less than 0, that means that k, so if I just go back and kind of slide that back in and just swap it back out, it should look like this. It'll be 49 over 8 is less than k. Now that tells me like that's my boundary. When k is equal to 49 over 8, and that's when my equation will have exactly one root. But if k is greater than 49 over 8, so k is like somewhere on the right-hand side, somewhere over here, this is where I get no real roots or no solutions. If k is on the left-hand side, which means that k would be less than 49 over 8 over here somewhere, this is when I would get one solution. Or sorry, not one solution. What am I saying? I would get two solutions. My mistake. And if k equals exactly 49 over 8, this is where I would get exactly one solution. So every time I am trying to figure out, whether for an example that looks like this, where you don't know what C is, if you're trying to decide what to do, if you set, all you have to do is just set b squared minus 4ac equal to 0. As long as you set this to equal 0 and then just solve for k and replace c with k and just solve for k, you'll be able to find that boundary of, okay, if I'm on the right hand side of that value, then I'm going to get something that's has no real roots. If I'm exactly at that number, I'll have exactly one solution. And if I'm less than that number, then I'm going to have two solutions.